let's turn our attention now to factoring instead of numbers, polynomials. And when we talk about factoring, we're going to consider really polynomials with integer coefficients. So there are variables, powers of variables. The coefficients are integers, no fractions, no irrational numbers, only integers. And let's consider the question of a factor. So a factor of an integer is an integer that I can multiply by another integer to get the original number. A factor of a monomial is a monomial that I can multiply by another monomial to get the original monomial. A factor of a polynomial is another polynomial that I can multiply by a different polynomial to get the original polynomial. These are the same concepts, just applied to different kinds of objects. And so, as an integer, 5 is a factor of 30 because 30 is 5 times 6. As a monomial, 3x squared is a factor of 9x cubed y because 9x cubed y is equal to 3x squared times, well, to get 9, I need to take 3 times 3. Right? To get x squared, I need to take x cubed times x. And then there's no y here, so I need to multiply by a y. So 9x cubed y is 3x squared times 3xy. And so 3x squared is a factor of 9x cubed y. 4x plus 3 is a factor of 4x squared plus 3x, because if we multiply x times 4x plus 3, we get 4x squared plus 3x back. Right? And x by itself, this is a polynomial. Right? So 4x plus 3 is a factor of 4x squared plus 3x, because there's another polynomial I can multiply it by and get 4x plus 3. Okay, so that's what it means to have a factor of a monomial, to have a factor of a polynomial. When we factor a polynomial, so when we use this word as a verb, our goal is to rewrite our polynomial in what's called a factored form. What does it mean to be in a factored form? It means that our expression is written as a product of simpler expressions. That is, if we were to evaluate it, the last step would be multiplication. So just to see a few examples, 3x squared times y, this is a factored form because all of the parts are multiplied together. There's only multiplication in that expression. You might be thinking, what about that exponent? Well, that exponent is really just repeated multiplication, right? This is 3 times x times x times y. Okay, this next expression, this is in a factored form because if we were to evaluate that, the last thing we would do would be to multiply. The reason that the last thing we would do would be to multiply is that everything except for that multiplication is in parentheses. On the other hand, this expression is not in a factored form because if we were to evaluate, this subtraction would be the last operation. There's subtraction outside the parentheses, so that subtraction would be the last operation, so that's not a factored form. Similarly, this is not a factored form because it has addition and subtraction that will happen last. This expression is in a factored form because, again, all of that subtraction is in parentheses, so the multiplication happens last. And this last expression is not in a factored form because that addition will happen last. Now notice that Since monomials are entirely put together out of multiplication, monomials are automatically factored. Any monomial is already factored. So if you see a monomial and you're told to factor, you say, well, I'm done because it's already in a factored form. It's only polynomials that we're going to be interested in factoring. Monomials we can just look at and see what their factors are.